Good morning everyone and welcome back to the new video. In this video we will cover chapter 26 of John Sear book that is based on exotic option, and the exotic option is very essential part of our financial system that help banks to earn extra money. And let's cover what is exotic derivative or exotic option. Okay, let's go to our board. We are on 26 exotic option, also called as exotics, simple exotics. It is derivative, derivative, or let's say in this case option that is tailored according to buyer needs. So it can have a different payoff payoff based on average, maximum, or barrier, or it have different maturity date, maturities, or different exercising date. You can exercise between finite intervals, or it can be completely different, right? It is tailor made, and it is more profitable for banks, for institution that make the option than vanilla option. So simple European option is called vanilla. Vanilla means simple, right? It is vanilla ice cream. Vanilla ice cream that plain color, and if we add strawberry into vanilla ice cream, it become strawberry ice cream, and that's the whole concept of naming vanilla. It is like plain ice cream, simple vanilla, vanilla option. Okay. So first we will cover. Let us see how many derivative we will cover. We will cover package first. Let me change the pen. Second is our perpetual American. We have seen it our option class in our option class. Third is non-standard American option or Bermuda option. Okay, gap option. And after gap we will cover forward start option. We have seen it forward start option. Secret option. Compound option. Choosers option. Okay, and barrier option, that is one of the important option. Then it is binary option or digital option. Cash or nothing digital option, you can say. Cash or nothing. Then look back option. Where it is south option. Thirteen Asian and Asian option. An option to exchange asset exchange option or exchange option. And two more. One is option involving several asset, basket of option on asset, several asset, volatility and variance swap, and we will see static option replication. So this is all the simple kind of option, and it is explained in very brief in, and so we will explain it in very brief, and you can see the pricing and how to do numerals of each pricing, each option by your own. And let's start with our package option. So package option is like it have call and put both such that there is no charge required required okay, no charge required to enter into contract, like uh like forward. Wait a minute, it is like range of forward contract. So we will buy wrong call of high maturity, high strike price K2, where is K2 is greater than K1, and we will short our put with low maturity. Okay, am I right? Next, I'm right. And in this way, the payoff, if let's say A equal to core option CE minus RT. Okay, so our payoff would be simple. If our call price is this, and so we will pay for put as much as A. So our payoff would be simple, ST minus K 0, and that is minus A. So our final payoff is max of ST minus K minus A equal to minus A. That is equal to this same, and that it is also called as break forward, Boston option, forward with optimal exit, forward with optimal exit, like that. Let's go to perpetual American for our input. So we have our BS differential equation with respect to time plus R minus Q equal to S with respect to S plus half sigma square S square second order derivative with respect to S equal to RF. This is BS, right? And if we use this for pricing of American perpetual core option, where payment is done only when S equal to H. Our spot price equal to some value that we set, and our payment is also a fixed amount of Q. That is perpetual American option. And let's say for the first time we have a boundary condition S greater than H. Okay, so H is above S is down, and if let's see our F equal to Q, that means that we hit the boundary, and where S equal to H we hit the boundary, and then F equal to 0 and S equal to 0. Okay, so to price that we start from 0, and let's see they hit. So our final value would be Q raised to H upon alpha, and that alpha is a positive term, and alpha is given by value our ODs. If we up give this value, the payoff, sorry, the payoff I brought here, and here is a Q. Okay, and if that if we solve, put this value in our equation F value and solve the differential equation, then final value is 1 upon F. Do you want me to solve it? Should I solve it? It is simple maths. Okay, F minus 1 sigma square equal to R, and in this way we get our formula. From this we can find the alpha value. Alpha is some positive value, and then if let's see alpha equal to alpha 1, then our value is alpha 1 equal to minus omega plus omega square plus 2 square R square. Okay, where omega R minus Q minus sigma square root divided by 2. That is our formula for pricing of. So it follow the value of derivative must be, so final value would be this. Okay, and for a put option, sorry, so for American call on perpetual, American call perpetual option, so we can say that if pricing would be, if H equal to H, the payoff would be H minus K, right? And from a result we can prove the value of option is H minus K, that is our Q upon S upon H alpha 1. So it is the asset price at T. So our H1, if H equal to H1 equal to K alpha 1 upon alpha minus 1, just open this equation, then our price of call option where H is greater than spot price is H minus K S of starting price upon H1 alpha 1. This is our price, right? We found this here, and then it is equal to K upon alpha 1 closed form solution upon alpha 1 minus 1 upon alpha 1 S upon K and alpha 1, and where alpha 1 value is given. Okay, I hope you get the idea. It's simple. And if it is American put option, so it is like if S is greater than H, we have to immediately exercise. So our value would be S minus K. So now let's value put option, and put option is simple. It is just S2 is greater than H, it should be greater, and K minus H2, where H2 equal to K upon alpha 2 upon alpha 2 plus 1, and that is simple SO upon H2, and that equal to minus alpha 2 K upon alpha 2 plus 1 alpha 2 plus 1 alpha 2 S upon K minus alpha 2. Okay, this is the put option, and the alpha value is only sign has been changed if you observe closely, and that's our perpetual option, right? Now let's see non-standard American option. So first type of is different maturity. There is a kind of option where exercising is on selective date, and that is called Bermudian option. Okay, and option where early exercising is allowed only for short period of time. After rocking period, like stock option. So for 2-3 years you can't exercise it, then you can exercise it. And third is strike price change during the life of option. For this you can use our, let's say, binomial tree model will be best. And now let's see another type of derivative, 26.4, that is gap option. It is a type of option where we have two strike price, K1 and K2. You can think like as K2 and K1. If the option price is above K2, okay, if ST is above K2, then our it is European call option. Okay, so remember that. So our payoff is would be ST minus K1, ST minus K1 if it is above K2, and the incremental change with payoff ST upon K2 would be K2 minus 1 K1. That would be this would be changed, right? And its pricing is simple. We make slight change in our BS formula, and that is SO E minus QT upon ND1 minus K1. Here K1 is there, remember that. E minus RT, probability of exercising, and D2, and our D1 equal to Rocky theorem of SO upon K2. Here is K2 plus R minus Q plus P upon sigma D, and D2 equal to D1 minus the price in the formula is greater than the price given by BS formula for a regular option with the strike price K2 by. So the price of this would be greater than European option with strike price K2 by this quantity. Okay, and now if it is exercise, if it is between K2 and 1, we said our payoff would be K2 minus 1. The gap option is greater than the holder of a regular option K2 time minus 1, and payoff of put option is such that when K2 is bigger than ST is same, I guess. Okay, that's the gap option. Forward start option is this option. Let's say we are at T0. Let's say that the option would start at T1 and T0, T1, or like T1 and end at Tn. So we will enter into contract at T0 and our option would start at T1 and will be will expire at Tn. That's the forward start option. And so forward start option let's say E minus RT at start is 0, right? At start is 0, like a forward. At start is equal to 0, and so value of our option at 0 at time T0 is T1. We discount it T1 and call price upon S1 upon S0. S0 is today's price S0 and S1 is at T1 priced. And in this way you can find the expectation in this neutral world, and SO is unknown. SO is known. We know SO. We don't know S1. Okay. SO is unknown. So that expectation of S1 equal to SO ER minus Q upon T1. Okay. And the value of forward start option will be call price equal to E minus Q T1. And that's the forward start option. Let's go to secret option. I don't know how to pronounce it. Chiri wait option. Let me see what is the pronunciation.
The word clique is pronounced with a strong C sound followed by the sounds li and ket as in click it. The li is a short I sound like in sit.
Okay.
The
Cricket option. So we have our cricket option now. We are at 6th option. Cricket option. So cricket option is a option. It is called as a strike reset option, and so at every timestamp there is a rule determining the strike price. The rule can be anything or tailor made, but let's see. Take an example. We have a option, okay, that goes to T1, T2, T3, and T4, then till Tn, mature at Tn. So our first payoff would be, so our first strike price would be SO at the money option, right, at T1. And okay, so it will last between T1 and T2, and after T2 the payoff would be at T3, but the strike price would be spot price at T2 S2. So then our third payoff would be at T4, and our strike price would be the spot price at T3, and like that our strike price will change with respect to spot price at every interval, and every interval our spot price will become our strike price, and it will give a payoff to next time stand. And in this way the cricket option is work. And let's see compound option. We have compound option is simple option is compound option. We are at 7. Compound option, so it is option on option. So we have core on core on put on core on put. Look, put on core, put on put. And we have two exercise state. First is T2 and first is T3. First exercise, T1 and T2 is of first option, and second exercise date is underlying option. Okay, and to exercise then anything here. The core option give the holder the right to buy a asset for second stock price. Okay, consider for example we have a core on core. So what does it mean, core on core? So on first maturity, on first exercise date, the buyer or entitled of core option, compound option, is entitled to pay first strike price K1 to receive a core option. So he will give K1 to receive at T1 to core option, and core option give the right to buy underlying asset. So we simple core option will give right to buy underlying at K2, and this is the core on core. And then its formula, it's little bit same than BS. We modify our BS formula. MAB is CDF of bivariate normal distribution. It is MAB is a, sorry, okay, CDF of distribution. The bivariate distribution is like we have a two normal distribution. So in 3D place there would be a another cone shaped distribution, that is bivariate distribution, that will have a probability of both. So it is like inner joint probability. Okay, I hope you understand it. So the core option on core is pricing would be like this: SO minus EQT and value of our CDF minus K2 E minus RT2 value of our exercise probability of exercising, and A1 is our BS where SO, let me the S star is asset price at T1. Okay, S star is, and SO is asset price at starting. Okay, and K1 and K2 we define it, and this is the formula. So European core on put is this, put on put is this, and it is put on core. The formula is this. You can check in the book. And let's go to another chooser option. Like in the name, there is a word choice. It is also called as a you like it of option. And it's simple. It give a feature for a specific time in our contract duration. So let's say our contract duration start at T, end at Tn. So at T1, the chooser, the holder of option have a right to make it core option or put option. So in a simple way, holder can choose whether the option is core or put. So till now it is option, and at this time we have a right that it is core option or put option. Let's say if we speculate that the price would go up, then the price is going up, then it is a core option. And if the speculation is the price is going up, then we can convert it into put option. So we have a right. So its payoff, it's simple: max of C and P. Okay, the value of chooser option, the value chooser option. Okay, and by put call parity, we can find the value of option in proper way. Maximum of C and P, okay, equal to max C. We will convert P equal to our formula minus stock price discounted with yield equal to C plus, we will common it out C. Okay, C plus discounting, we can put it T2 minus T1 dot max of 0 with strike price K minus R minus Q T2 minus T1 minus S1. Okay, and that's the formula to find the value of call option. And it's so chooser of option package consists of a call option with strike price K and maturity T2 or call option. Okay, plus we have E T2 minus T1 put option. This is put option with strike price K equal to E minus Q, T2 minus T1 and T1, and this is compound option. Okay, let's go to barrier option. So let's talk about barrier option, right? We are on barrier option. So by the name of option, there is a barrier. You have to understand that there is a barrier H. Let's say H. Okay. We have taken two barrier and our stock price is going in between this. Okay. Let's say there is a type of knock-in barrier option. Knocked-in barrier option. The thing is, like, let's say this is our barrier, and if it reach about this, then the option, so the option exit. If it reach above it, then only it exit. Else its value is zero. If the stock price or a ST is above the barrier, cross the barrier, then the option exit. Otherwise it doesn't exit. That is knock in barrier. And another, then second one is knockout barrier. Knockout barrier. If the stock price is above certain limit, that is H, above our barrier, then we are out. So the value of our contract will be zero, and it will exit if the contract is below that barrier. So there are, like, down in down in core. If if the if the option is below the barrier, then it is core option. There is down in put, it is a put option. If it is below, there is down out core. If I'm right, down in and down out, there is a down in core. Let me up and in core, down and out. Okay, down and out, right? Down and out. If it is below, let's say it go below this, then the value of contract is zero, and it will be contract exit only if it's above the barrier. You have to understand down in means inter money and out means outer money. Simple. If down in means if the contract is below that contract, then it is inter money. Down in put means the put is inter money. Down out call means if it is let's say goes below that, around below the barrier, then it is out of money. And down and out put, we, and there is up in call, up and in, up input, down and out, sorry, up and out call, up and out put. So up in call, if the stock price is below the about the barrier, up above, then it is inter money. Up in about the barrier, then it is inter money. Up and out call, if it goes about this barrier, then it is out of money. And up and out put is, if it put price goes about the barrier, it is out of money. And it's simple, and the pricing is also the simple. It is simple BS formula. You have to think of BS formula. So let's take H, our barrier level. H is less than equal to strike price. Okay. So the value of down in call, if the price is below the H, then it is inter money. In call is zero. At zero time is, at time zero is CD down in. The barrier upon this is the formula, and the lambda is given by this formula. Simple. Because of the value of a regular call equal to value of a down in call plus the value of down out of call. So uh, it is, you can, the regular call option give the value of a down in call plus the value of down out of call. So C do call price out, down out equal to call price minus down in. That is the formula DI formula is down in, call formula is this, D out formula is this. Okay, and if let's say K is here and H is here, okay, with down out, the down out formula is given by this formula, and down in formula is same like inverse. Okay, inverse of this, where the function, you can see the x function and lambda function is given. And let's see up and out, if it go above this, then it's out of money. Okay, and up and in call means if it's go above that, then only it is regular call option come to exit only if barrier is reached. Okay, that is simple. That is up in, UI means up in, and its formula is this, and CU up out formula would be this. And for a put barrier, if it's above that barrier, then put will exit, otherwise it will not. That's the formula. It's simple. You have to remember the formula. You have to get the intuition where is the barrier. It is up in, up out, and if H is less than equal to K, if S is less than, K is here, H is here, and it is put option. Okay, K value should be always bigger. And put out, if it is go beyond H, then it is out of money. So our payoff would be in between this, and we use this because it is cheaper. Payoff is also limited to barrier. It is not unlimited payoff, and that's why it is cheaper and it is easier to hedge. It is cheaper than European option, and that's what I want to say. And it is simple. You can understand it. Okay. And another disadvantage is that it's there is a spike moment in the market, right? There is sudden spike, and the spike is very for rest. Spike is for very millisecond or very for a rest period of time, and that can cross the barrier, and that can make our derivative out of money or into money, and that's not good. And another, and barrier is for or on match or period of time. So there is number of time it will be out of money, into money, and it is very, let's say, it is not favorable, right? There is high volatility because of it, and it discontinues payoff. The so payoff function would be discontinued because of this. So there is an option called a Persian option, that say the average, or if the barrier is about 75%, if the stock price is above 75% of time, the stock price is about the barrier, then only the payoff would be here. So there is a limit. In this case, there was quite fluctuation because of crossing the barrier several times. And yeah, Monte Carlo simulation is can be done for this pricing. Let's say binary option, cash or nothing option. Binary option, cash or nothing, sigmoid function, you can say that. If the strike price is 0 ST, then there will be fixed amount of payment, or S would be 0. So payment would be fixed, let's say Q and 0. So maximum of Q and 0, if I am right. Fixed amount Q, right? If strike price is above Q for a call option, for put option. So the value of cash or nothing call would be just probability of it closing going above. That is Q, fixed amount, value of option, and D2, just simple cash or nothing. And for cash of nothing put would be same negative probability of exercise, not exercising. Okay, and discounting is done, and that's cash or nothing. Now let's see look back of option. So the stock price goes at for a stochastic process. So at maturity we see that if the stock price has crossed the maximum x max or a set limit will cost the maximum amount, then the payoff would be the x max payoff would be there would be fixed amount, then only. So look back option is like we look in the history and see that is our stock process has reached maximum amount or a minimum amount we set for a put option, we would say minimum amount, and that's how the look back option work. So it is maximum or minimum asset price during the life of option. There is a term like floating call. Okay, so floating call option is call option where payoff would be the ST, the stock price at time T minus maximum. So it is the minimum. Okay, for a floating look back call option is the amount of a final asset price, that is ST, exceed the amount of a minimum asset price achieved during the life of option. So let's say our process had minimum of 100. Okay, and then ST is of 200. So our payoff would be 200 minus 100. Then we discount it and we price it. And the pricing is little bit complicated because we have to see the part dependent of it. And so pricing would be like this. It is BS pricing where S is this formula is given where A1 is given like this, A2, A3, and Y4. Okay, and that is A1 is log of it is BS formula slightly changed, and S min is a minimum asset price, we know that, and after the S min is such that we go to SO. Okay, right, and for a put I have given it for a put, it is put, yeah, for a put the equation slightly changed, k minus this and this is for a put option, and there is fixed look back. So this equation, because it is part dependent, the one example I am given here, it was example of fixed. We knew that minimum was fixed, and it was just simple European then. So fixed look back call option is a payoff same as a European call option, except the final asset price, that is ST. S, ST is replaced by minimum asset price, is replaced by minimum asset price. So it payoff X max equal to X maximum of K. Okay, replaced by minimum achieved during the defined X max. Okay, Then our call price, call fix would be uh, because of pull call parity, call put parity. Let me show you. Wait a minute, sorry. So pull call parity, because of pull call parity, let me show you. It is on my other screen. So the value would be this. The P star, let me, okay. And for a put price, this would be. And let's go to shout option. So it is European option, okay. Option where there is a feature of shout to writer of option. So in simple case, it is a European option whose payoff would be maximum of whatever st minus k is, or the shout in intrinsic amount of shout. So let me tell you, explain you how. So let's say today stock price is at 50, okay, and it is moving, and it reached to 60. And here we shout it, shout it, and to the writer of option, and then the payoff would be like, if the price is below 60, if let's say at t, we are at t, if the price is below 60, then our payoff would be intrinsic value of, that is, this is tau I, that is tau I minus so that is 10 rupees. And let's say if it is below above 60, then let's say it is 70, or the st. So our payoff would be simple, st minus k is 50, strike price is 50, sorry, strike price, it is at the money, so equal to k, so strike price is 50, so that is 70 minus 50, 20. So if stock price at maturity is below the shout amount, then the payoff would be intrinsic value after discounting e minus rt, intrinsic value of our option, sorry, our shout amount. And if it is above our shout amount, then it will be the simple European option, and its payoff would be simple, maximum of 0 st minus s tau, this is shout amount, okay, plus shout amount minus k. So this is the payoff, you can see by yourself, and it is cheaper than barrier option, and work some kind of barrier option only, but still. Okay, binomial tree or trinomial tree can be used to price it. Now let's see Asian option. Okay, for Asian option I have to put out here. So it is an option where st doesn't matter, the s average of whole stock price matters. So our payoff would be k minus S average, okay, for put, and S minus K S average for call. And in this way the stock price matter. So Asian option is the payoff depend on the arithmetic average of the price of underlying during the life of option. Okay, and it is cheaper, more affordable, less volatile, and more what we say, sorry, more beneficial, no, mm, more suited for hedging. Okay, so corporate prefer this over the European sometime. And let me show you the payoff, I guess. The payoff is like we are suppose M1 and M2 are the two moment. One moment is mean, second moment is variance. So mean of and variance formula is there, then we expand it, put the value of everything, and then we get the final formula to find the variance. So we found mean by this formula, variance by this formula, and after that we can just modify our equation. It is actually maths is complex, in book it is very easy. If you want I can show you the Asian option, but I have done pricing of Asian option using European. So let me show you Asian option. Okay, exotic derivative pricing. Asian, we have Asian, we have barrier option, we have digital cost, that is digital option. We have three options. Okay, net to conquer. We have part dependent option. We did Monte Carlo simulation. That is our payoff. You can see mean payoff of S, mean payoff of core. Simple payoff valuation would be this, and we use Monte Carlo part. That is our stochastic differential equation. We perform Monte Carlo simulation over here. This is our Brownian motion, and then this is the important part, I guess. Let's see. Part is 5,000. We set the parameter, have our part, then payoff X would be maximum. The payoff formula would be S minus K and K minus this. So if we record this formula here, mean of payoff. So we are calculating the mean of payoff, and it's simple. And in this way, we perform the mean pricing of Asian option. Let's see barrier option. Sorry, barrier option notebook, barrier notebook. बैरियर का नोटबुक नहीं है, होएगा. Okay, it is a barrier notebook. Up in active, the expert goes above the barrier, down in active, below the barrier. I explained this all stuff. Monte Carlo simulation, digital payoff would be same, and formula is different. Digital payoff would be C, mean of ये exponent, discounting of mean of S and mean of A for digital payoff. Okay, and I think This is for Monte Carlo part. Okay, here we decide the barrier. We decide the barrier. If it is about hit, the summation value would be hit vector, means the vector, the value of option if it hit equal to 0, and then we find the mean of payoff. Okay, it's simple, and that's the pricing of barrier option. And digital option is simply 1 and 0, I guess. Call price exponent mean of payoff, return p of payoff. It is for Monte Carlo, I know it. Let me say where is a digital option. Oh, okay, if CP is option it is plotting, payoff is 11. Okay, barrier option, valuation of digital. Okay, we plot the digital histogram and we plot the price of option. You can see digital is expensive, and that's some exotic derivative we covered. And let's fast forward to, let's look from the book. Okay, option on a one accent, sometime option to another accent. So the entire, the thing is, option to extend one asset from another asset, something refer to extend option, you can understand it. And option to buy yen and Australia point of view. So it is option that we exchange to another asset. So if at maturity we will deliver another asset. So consider you have an option to give a asset worth ut at time t and receive the in return the asset worth vt. So the payoff would be simple. We will give worth of ut and we will receive the worth of vt. So there is exchange in the product. And here the example was an option to buy yen with Australian dollar is from a point of view of US investor, an option on exchange of a foreign currency asset for another foreign currency. So that is BS formula, which slightly difference VO and UO, and there is a correlation coefficient, correlation between two assets. And our value, an option obtain a better or worse two asset regard of position, one asset combined with option to exchange for another. So minimum UT equal to VT minus maximum. It is a relation function. An option involving several assets. So several asset means there is a basket of option, or the option has the payoff depend on several asset payoff. If the asset price ST of one should be above and both should be above. So there is a it is a complex to price, but European basket option you can see it. We use Monte Carlo simulation, follow geometric Brownian motion, and this is the what we say, sorry, momentum of our function. One is mean of fi, where fi is maturity, n is a number, t is the option, fin is a forward price, and m2 is our variance, and rho ij is correlation coefficient between I and j, volatility and variance swap. Okay, so volatility is sorry, where are we? Volatility and variance swap, it is a swap that change the stochastic volatility into a fixed volatility, or a stochastic variance rate to a fixed variance rate. You can see here. So realized volatility of an asset between 0 and t perspective for a fixed, and 0 and t, between the 0 t, the volatility formula is given by this. Okay, sorry. And S is highest of, so it is simple volatility swap where payoff would be L wall, L wall, Sigma dash is the constant stochastic volatility that we don't know. It is a fixed volatility, and rho is the notional principal. Okay, and in this way, and variance is just square of volatility. So variance rate is the square of volatility is a variance rate. So variance swap is the change in the variance swap for a single variance rate, and that is given by this formula. See, I told it is square. Okay, and valuation of variance swap. So it is a big expectation. If we solve this expectation, we get the expectation of value, and then we just have to discount this to find the value of our. This is stochastic. That's why we have to find the expectation, and then we find the discounted rate of this for a valuation of our swap. Okay, and another standard approach is this, where delta k is, suppose the price of European option with a strike price K1 are known. Okay, and K1 and K2 and Kn is a standard approach implementing this, and then by using strike price you can find the volatility, and the function Qt is the price of put option. If Ks is a core option, and if K is greater than Si, and K equal to the function Qt equal to average of a European and core price. You can read it and you can solve this. Nothing to explain here. And volatility swap is just simple expectation of this, and volatility is given by this, and the final value would be discounted by this. VIX index is a average of volatility. You can see that it is a volatility index that shows the change of volatility. A function can be approximated with the two function, and it can be with forward price and rock of forward price equal to this, and the mean of risk neutral community variance. So the variance is calculated by this formula, and that's the weak index and static option replication. So let's say we have an exotic option, and let's say barrier in core option. Okay, in core option, and we have to hedge it. So we will find most liquid product. So let's say most liquid traded product, that's payoff will be similar to our exotic product, and we will hedge it using our liquid product, that is static operation replication. So hedging the exotic product, a technique for a difficult case involves searching for portfolio actively traded option that is approximately replicate the exotic option, and sorting the position for hedging. So it is used for hedging. Let's say we have up and out money. If it go above up, and it is out of money, and 9 month with a strike price of 50, barrier of 60, volatility of 30, and our function would be this. So we have a two condition. If it is above below 60, then our payoff would be this, and if it's above, then our payoff would be 0. So to hedge the position, we divide our delta. Let's see, we divide our delta into timestamp. Okay, so divide to delta t, then choose a core option for a strike price 60. So it payoff would be if it is above 60, because above 60 we will face loss. So to hedge it, we will buy a stock price with this boundary 60 and minus 1 delta t, and it n minus 1 is, like, you can say how many time you have, it is delta value. N value is number of timestamp dt, like 1 upon n dt, right? So how many time you have divided your grade is n value, and that's the formula. Choose the European core option with strike price 60 at maturity and n minus t, and boundary condition of this. and in this way you can hedge our position. And that's the lesson. So I hope you liked my explanation, and thank you for watching. We will meet in next video. Bye bye.